Hello everyone, welcome back. In previous lecture, I explained about the classification of various machine tools. Now, and what are the motions? There was primary motion and auxiliary motion. And in today's lecture, I am going to discuss very important, that is the geometry of cutting tools and what are the various cutting tool angles and what is their significance. Like first we will start off with the single point cutting tool. So let us start. So cutting tool angles and their significance. So before that, let me give you brief about what are the single point cutting tool, how they look, what are the various types. So here there is first is the this is the solid type single point cutting tool, in which this is the there is nothing extra in this. This is the only solid type single point cutting tool. There is that is made from a one solid part. Okay, from cutting uh, cutting tool steel. Okay, so that is HSS, high speed steel. Okay, for machining. Then the another type is indexable insert type single point cutting tool. Here you can insert one insert. Over here there is a slot in the cutting tool. Here you can see there is one another type, that is the tipped type single point cutting tool. There is one tip over here, while in this there is one insert over here. You can see the combine of, here it is there is one insert, and here it is the seam that is provided for the to absorb the shock or load from the chip, or from the cutting to the this body of the cutting tool. Here there is a separate view how the insert looks like and how the seam looks like. Sorry. So the insert here is, when it gets weird out, we can change this insert. Okay, so these are the types of the cutting tools. So we will start with the geometry of cutting tool. So this is the complete geometry of single point cutting tool. Here you can see that this side is the face of the cutting tool, and this is the end cutting edge, and this one is the side cutting edge. The cutting action takes place by this side. Here you can see, suppose there is one workpiece which is to be cut. Okay, so suppose here I draw a cylindrical part which you are supposed to cut. So what will happen? The tool will be moving in this direction, and the cutting action will take place over here. So the so this is the simple diagram. It is when the tool moves from the right side to the left side, it is called as the right hand tool, and when the tool moves from the left side to the right side, then it is called as left handed cutting tool. Now further we move on. So this is the cutting edges, and this portion over here which actually cuts is this portion. is the nose part, that is called as nose, and this bottom line over here, this is called as the heel, and these sides are the flank. Okay, here there is one simplified diagram you can use to draw as well. So the top portion of this tool is called as the face, then this is the shank part. Okay, and this one is the bottom one is the base, and this is the side flank, and this one is the, on the other side there will be the end flank, but this edge is called as end cutting edge, and this one is called as side cutting edge, you can see. And the point where the end cutting edge and side cutting edge meet is called as the nose, and the top portion over here is called as the face, and the bottom one here is, it is called as heel. Sorry. So we will discuss them one by one in detail, what are the various angles, and how we are going to how what is the how we are going to define them. So next, here, if we take a cross section of this tool, we will it will look like this. If we take the cross section of here, so this will be becoming the side view, or we can say, sorry, this will be the front view if the view is from this side. So this one is, we will get two angles from this section, that is the back rack angle, and here, and there will be end relief angle of the cutting tool. Another section, if we take here, from here, this is the side from side view, then we will get the side rack angle and side relief angle. If we take cross section to the horizontal, it will look like this, and we will be having two angles. Okay, first one is end cutting edge angle and side cutting edge, and this one is the nose radius, you can see from here. So if we combine all the angles, this one is the front view, this one is the top view, and this one is the side view. And here the complete nomenclature of cutting tool is given. Let me show you once again. Then first we take the front view, and we will get two angle, that is back rack angle and end relief angle, and that is called as a wedge angle, wedge of the cutting tool. Second one we take from the side view, so that is called as side rack angle and side relief angle. And here from the top view, we cut the tool from the half, then we will get the end cutting edge angle and side cutting edge angle, as well as we can see the nose radius. Okay, so this one is the three view. Now we will discuss them one by one, how to define them. So the first is the back rack angle. Sorry, here it is the back rack angle. Now the back rack angle is the angle between the face of the tool and a line parallel to the base of shank. This is the shank, and there is a line parallel to the base of shank. This is the base of shank, and there is line parallel to the base of shank. Okay, and the angle between the face of tool, that is called as back rack angle. In a plane parallel to the side cutting edge. Okay, so जो plane होगा, that will be parallel to the side cutting edge. Sorry. The back rack angle affects the ability of tool to shear the work material from the chip. So here the actual shearing action will be taking place as the workpiece. We suppose here there is one workpiece. Okay, so suppose if we take one workpiece is to be cut from here, and there is a flow of chip while the cutting action takes place. So this way the flow of chip will remove from here due to this wedge shape action. Okay, so the flow of chip will be taking from this side and the curls will be formed over here. So this is the basic function of rack angle, to provide space for chip to flow. Okay, and there is another angle that is called as the side rack angle, and it is the angle by which the face of cutting tool is inclined sideway. Here the sideway inclination you can see. So this is called as the side rack angle. Now the third one we can see is the rack angle. These are the rack angle, but rack angle there are two types, that is positive rack angle and negative rack angle. Here this tool is having positive rack angle, that rack angle has certain value, but here the rack angle is always on the top side. Okay, and the side rack angle and back rack angle combine to form the effective rack angle. So the rack angle has two major effects during metal cutting. One major effect of rack angle is its influence on the tool strength. A tool with negative rack angle will withstand more far than far more loading than tool with positive rack angle. Here, the value of rack angle for this is the positive, but when the tool is having a flat face like this, suppose this is the, then this is called as a zero rack angle. And when there is negative rack angle, so the negative rack angle looks like this. So this is the horizontal face and the angle is in this way. Okay, so this is the negative rack angle tool. So the negative rack angle has advantage that it withstand more. As we provide more rack angle, positive rack angle, this portion becomes very sharp, and due to that the tool becomes weak. But in positive rack angle, the strength of the tool increases. The other effect of rack angle is the influence on pressure cutting pressure, and a tool with positive rack angle reduces the cutting force by allowing chip to flow freely across the rack surface. Now the rack angle has certain functions which it has to complete. Is the first function is to it allows the chips to flow for convenient direction, which means, as I explained earlier, it allows chips to flow in convenient direction. It reduces the cutting force that is required for to shear the metal. As there is more rack angle will be there, then there will be less cutting force required, and it improves the surface finish. Okay, and this is about the rack angle. Now the another is the relief angles. The relief angles are provided to minimize the relief angles. There rack angle in positive and negative I discussed. Then there is relief angles. So relief angles, there are two types: side relief angle and end relief angle. Relief angle are provided to minimize the physical interference or rubbing contact. Suppose there is the flat tool, so what will happen? The this will come in contact with the workpiece. This face will come in contact with workpiece, and there will be a rubbing action if this face is flat. Okay, so that's why there is angle provided so that the rubbing does not play take place. So relief angle are for purpose of helping to eliminate tool breakage and to increase the tool life. If the relief angle is too large, then the cutting tool may chip or break. If the angle is too small, the tool will rub against the workpiece and generate excessive heat, and this will in turn cause the premature dulling of cutting tool. Small relief angle are essential when machining hard and strong material, and they should be increased for weaker and soft material. A smaller angle should be used for interrupted cuts or heavy feeds, and a large angle for semi finish and finished cuts. Now, the first one is the side relief angle. So, the side relief angle, here it is the side relief angle, prevents the side flank of tool from rubbing against work when longitudinal feed is given. The larger the feed will require greater the side rack angle. ओके, सो जितनी फीड चाहिए होगी उसके अकॉर्डिंग साइड रैक एंगल डिसाइड किया जाएगा, क्योंकि जो डायरेक्शन होगी कटिंग टूल विल मूव इन दिस डायरेक्शन इफ यू व्यू फ्रॉम हियर. सो साइड रैक will be greater for if the greater feed is required. Now another angle is the end relief angle, and this end relief angle prevents the side flank of tool from rubbing against workpiece. So as I explained, it will prevent tool from rubbing against workpiece. A minimum relief angle is given to provide maximum support to tool cutting edge by increasing the lip angle, and the front clearance angle should be increased for larger diameter work. Now there is the cutting edge angle. So here you can see there is end cutting edge angle and there is side cutting edge angle. The side cutting edge angle, first discuss about this side cutting edge angle. The advantage of increasing this angle is it is increased tool life, as for the same depth of cut and the cutting force is distributed on a wider surface, and it diminished the chip thickness for same amount of feed and permits the greater cutting speed, and it diminishes the chip thickness for the same amount of feed and permits the greater cutting speed. It dissipates heat very quickly as we provide the side cutting edge angle. This angle is called as side cutting edge angle. Now, the side cutting edge angle of the tool has practically no effect on value of cutting force or power consumed for given depth of cut. Larger side cutting edge angle are likely to cause the tool to chatter. Now, the another one is the end cutting edge angle. End cutting edge angle. So the function of end cutting edge angle is to prevent the trailing front cutting edge of the tool from rubbing against the work, and a large end cutting edge angle unnecessarily weakens the tool. Okay, so it varies from 8 to 15 degree, and the last one is the nose radius. As we can see, this is the nose part, and the nose of the tool is slightly rounded in all the turning tools. The function of nose radius is the greater nose radius clear up the feed mark caused by the previous shearing action and provide better surface finish. All finished turning tool have greater nose radius than rough turning tool. Nose radius increases the strength of the cutting tool, and strength of the cutting edge and tend to prevent the wear taking place in the sharp point cutting tool, while the accumulation heat is less than that in the pointed tool, which permits higher cutting speeds. Now the next topic is about the tool signature. It is the system of designating the principal angles of single point cutting tool, and the signature is the sequence of numbers listing the various angles in degree and size of system. There are several systems available like the ASA, that is American Standard Association. Then there is ORS system, that is called as orthogonal rack system. Then there is normal rack system, NRS, and there is maximum rack angle system, that is MRS. Total for four systems are there, sorry, five systems. And in this I will explain about the ASA system. So in ASA system, this is the, you can see, this is the front view, this is top view, and these are the side views or end view here. And there is one section from inner side. Now the in ASA system, the angles are classified in this way. There is back rack angle, then side rack angle, then end relief angle, side relief angle, end cutting edge angle, side cutting edge angle, and there will be nose radius. So there is a proper sequence of writing this angle. So there will be first rack angle, and suppose the example is taken, there is value of rack angle is here, you can see. We have to write first back rack angle, that will be here, it is 8. This will be the back rack angle. Then there is the side rack angle. Side rack angle, here you can see, this is the side rack angle, that is the 14 degree. Then we write down the relief angles, or the relief angle in which we have to write first the end relief angle, that is the 6 degree, and the side relief is also 6. So they will be both same. Next, we are supposed to write down the cutting edge angle. So the cutting edge angle, here there are two cutting edge angle, in which first we write down the end cutting edge angle, and then we will write down the side cutting edge angle. So the end cutting edge angle here is the, here you can see it is end cutting edge angle, that is 20, but here it is the side cutting edge angle is 15 degree, but here there is end relief angle and end clearance angle, that is 12 degree, and normal side relief angle is this. Okay, so the end cutting edge angle, here it will be the 6, and the side cutting edge angle is 15. Okay, suppose. So in this way we can nomenclature, give the nomenclature, and finally we write down the nose radius in ASA system, and here the nose radius is suppose 1 mm, so that will be the nose radius. So the first we write down the back rack angle, then there will be side rack, and we will write end relief, side relief, then there will be end cutting edge and side cutting edge, and last we will write nose radius. So in this order we will write down in the ASA system, that is the American Standard Association, that is the ASA system. So this will be the first, in this sequence we have to write down in the ASA system, and we can design any, give nomenclature to any cutting tool. So for abbreviation we use BR for back rectangle, SR for side rack, ER for end relief or SR for side relief. Then there is end cutting edge angle, ECE or SCEA, that is for side cutting edge angle, and NR for nose radius. These are the short form we use for various cutting tools. Here also I have mentioned the various angles are mentioned as well, and here it is written with the abbreviation. So with this I end today's lecture. So today I explain about the single point cutting tool, its complete geometry and tool signature. Thank you very much for listening me carefully. Have a nice day.